Alright, what's going on, guys? Welcome back to the Derv Codes channel. Today we will be solving LeetCode number 238, product of array except self. So the question states that if we're given some integer array, we want to return an array which at each index I of the array, we want the product of every number within the array besides the elements at that index I. Okay, and further, they want us to write an algorithm that runs in O of n time without using the division operation. Of course, with the division operation, be very simple. We just take the product of the whole array and then divide that product by each element. We also want to use O of 1 extra space, so the output array does not count as extra space in this case. If we're considering index 1 of the output array, what we'd do is we'd multiply these three elements in the array. Index 2, we would be multiplying 3 times 4 times 1. What we can do is multiply the product of the values on the left with the product of the values on the right. So essentially, if we're at index 2, we want to keep track of product of all the values to its left, and if we're at index 1, we just want it to default to 1 since there's no values to the left, and we want to use this product and multiply it by the right product. So anything other than 1, let's say it was 0, would produce an output that we actually don't want. Okay, so how would we do this? So let's run through this example over here. So if this is our output array, since we don't want to use extra space and we somehow need a way to keep track of the product to the left of some index in the array, right now we're only considering the left side, right? So the output array can default with the first value as 1, since to the left of 1, the product will be 1, and then 2 will be 1 again, and then 3 it will be 2 times 1, 4, 6. Now we want to actually build the output array, and to do that, what we'll do is we'll keep some sort of accumulator for the values to the right. So we'll do one more pass backwards through the array, and we want to take the product of the right values and then use these. So the product of all the values to the left of the current index, we want to use those and multiply it by this accumulator that we have to the right, which will keep the product of every value to the right. So this accumulator, for example, as we go backwards through the array, so it starts off at 1, we'll update this output array and with the value 6 times 1, because that's essentially every value to the left times every value to the right. Okay. And then we'll update that with 6, and then we'll update the pointer, so now it's at 3. Now we want to check the product of every value to its left, and we want to update our accumulator with this value. So what we do here now is we want to update this index of the array, so it'll be 1 times 2 times 4 in this case, so 8 in the output array. And then we want to update our accumulator again. And as we can see, this is O of 1 extra space and linear time just because we do 2 passes through the array. The reason we don't use n extra space in this case is because the output array doesn't count as extra space here. So it's a little trick that we can use. Alright guys, welcome back. So essentially for this video solution, I'm going to start by just having the code out and then explaining it. Okay, so first we start with an output array, and then we need an accumulator from left to right. Essentially what this is keeping track of is just, if we're at some index I, what is the product of all of its values to its left. And then accumulator from right to left is just keeping track of, as we iterate backwards through the array, what is the product of, let's just say we're at 3 as we iterate through the array, we want to check what the product of the values to its right are. Okay, so to start, we'll begin by building our output array. So essentially we start with an empty output array, and we begin by assuming that the accumulator left to right value from the last iteration just gives us the value of the product of every element in the array to the left of some current index. And essentially what that allows us to do is just add it to the array. So in this case, if we consider the very first iteration, so I equals 0 of the for loop, we'll start by assuming that the product of the values to its left are correct. Okay, so that is true because we initialize accumulator left to right to just be 1 in this case. Okay, and then we need to make sure that it's true for I equals 1, so when we get to 2. So what we do in this case is we just multiply accumulator left to right by this index 1, so that once we enter the for loop when I is equal to 1, what happens is that we have the product of all values to its left. And essentially we build that array where each index that corresponds to some index in I just keeps track of the product of every value to its left. So if we consider the output array that was built from this for loop, this is what it will look like for example number 1, right? And then what we want to do is we want to iterate backwards through the array, keeping an accumulator for the product of the values in the nums array to the right of some index. So if we're at the last index, the product is just 1. And we'll do the same thing where we assume at the beginning of each iteration of the for loop that the product to the right is correct. And we need to keep that assumption true throughout the entire for loop. So we do that, of course, by changing the accumulator from right to left at the end of the iteration to include the current value. So if the index is 3 in this case, then it'll include the value of 4. So it would be 4 times 1, and then we can use the same assumption as we decrement the value of I. Okay, and each time as we're doing this, keeping the product of the values to the right of some current index I, we also want to be updating the output array. So if we're over here and we have the value of the accumulator from right to left, so the product of every value to its right, but we also have the product of every value to its left just by looking at the current index, well then we just want to update the out array at index I to be the right product times the left product. If we do that for every element in the array, we get a proper output array. And if we run this, we get the correct output. And it's pretty efficient. All right. Thank you guys so much for watching. I'll catch you in the next one.